So the next speaker is KYOUNGSEOB BYEON from Child Mind Institute, and the title of his talk is Deciphering the Dynamics Spatiotemporal Maturation from Childhood to Adolescence.
Thank you for. Hello, everyone. My name is KYOUNGSEOB BYEON from Child Mind Institute, and I'm postdoc fellow in there. And today I will be presenting our recent work to study the neurodevelopmental changes in functional dynamics. So as the first presenter said, the neurodevelopment follows the sensory to association axis. And our study was inspired by functional gradient study published in 2021 in children before age 12. Oh, should I use the pointer? Sorry. Yeah, in children before age 12, the dominance axis follows visual to sensory regions, while after age 12, the sensory motor to association axis become dominance. So our research question was that how functional dynamics contribute to this change of the gradient. Quasi-periodic pattern is a recurring 20 seconds long spatiotemporal pattern in resting state fMRI. And conventionally, this pattern was captured by sliding window approach with fixed window length. And resulting pattern represent the propagation of activities across cortex, like in the right video. Recently, a study published in Nature Neuroscience suggested a new approach to capture the spatiotemporal patterns, so-called complex PCA. Most distinct feature of this method is that it decomposes complex numbered analytic board signal, which can represent the temporal phases of each moment. And this approach makes it possible to represent the recurring pattern by temporal phase instead of time, like from 0 seconds to the 20 seconds. So in this pattern, we can see that the activation propagate from sensory regions to attention, association, motor, and again sensory regions. And the others pointed out that the functional gradient is just snapshot of, but the snapshot of the specific moment of this functional dynamics. So in this case, it could be the moment at the phase pi here. Before to check the age effect on this pattern, we checked its robustness. And we found that the first three patterns explain over 50% of total dynamics. And the patterns were highly reproducible. Yeah, we checked 4 independent cohorts, and we compared their spatiotemporal patterns to each other with similarity measures, and it shows pretty high. And the patterns are also highly reproducible and reliable too. Even with the different scanner acquisition to each other. I mean the temporal resolution. So we captured the subject-specific patterns from subjects with age range between 8 to 23 years old, and then compared its similarity with adult pattern, so adult reference pattern. As a result, we could observe that the similarity itself is high while showing the strong trends getting more adult-like pattern. By this way, we could convince that there is enough age effect in this pattern. And regarding the gradient shift in youth, our hypothesis was that it might be related with the amount of time spent by individuals for each propagation. So we defined moment-by-moment state with the dominance pattern at the time and measured the occurrence ratio of each state. In children, individuals spend only 30% of total time for this sensory to association propagation. On the other hand, the adults spend around 40% of their time for this pattern. However, individuals spend less time for the pattern 2, which follows the sensory to visual propagation as they grow, which follows as they grow. Further, we checked whether this pattern, there is a shift of directionality of this propagation. And last year, a study showed that the top-down propagation of both signal is getting dominance along development. They used the optical flow estimation, which is computer vision technique to capture the local propagation. And our resulting pattern of our so the result pattern of our hours have a temporal phase by moment, and it makes it possible to check much detailed change regarding this top-down directionalities. So what we observed here was that amount of time individuals spend for bottom-up propagation from sensor to association, much more specifically from the attention to the association and propagation was decreased as they grow. Further, whether the top-down propagation is really related with the top-down processing, we tested predictive performance for cognitive score. And the result indicated that the top-down propagation could better explain the cognitive function slightly. We further checked how the fluctuation of each region changes within youth. Since this pattern have activity fluctuations for each regions, we could measure the wave height like this, for these fluctuations. The fluctuation was getting increased in youth, while in some regions regions showed the negative, so decreased the wave height. So this change of the regional fluctuation was highly heterogeneous. Especially for pattern 1, both sensory and association network showed increased fluctuation in youth. By this, we can presume that the reason why the variation of functional gradient was increased in youth. So in conclusion, our research question was to figure out the contribution of functional dynamics for the gradient shift in youth. And our results indicate that amount of time spent by individuals for a specific propagation pathway can drive this change in functional gradient. And further, the maturation of the pattern also can be captured by its directionality and the regional fluctuation. And I would like to thank my mentors and collaborators for their support in research.
Thank you for that wonderful talk. We have a little bit extra time for questions. So any questions from the audience? Yes, please speak up, yeah?
Have an effect in age effects, a negative and positive, right? Yeah. As you show in the previous slide, this slide. So the summary slide is like we observe the top-down and the bottom-up propagation has a different effect in age, right? This one is positive and the other is negative.
Yeah.
And I just wonder, because we all know we need the balance between top-down and bottom-up propagation. So how to interpolate? They have a different effect in age. So it means like when we we need to keep the balance between top-down and bottom-up, right? But we observe a different effect in age. So how you interpolate that?
Yes, so in aspect of the cognitive function, I think that in children, they rely more on the sensory processing, like the children tries to touch everything, testing everything like that. So the learning system of them is done by the sensory processing. While they getting mature, they rely on more time for the abstract thinking or reasoning to learning some new stuff. So yeah, my guess was that it's the reason why the top-down propagation is getting dominance also in the previous studies and these studies. So was it correct answer for your question?
I just want to link like symptoms. For example, like delusion in schizophrenia, they have a strong top-down like propagation, and so it means like they have a stronger top-down compared to the bottom-up.
Yeah.
And here it's like we observe the dominant top-down effect. So I just wonder, is there an imbalance during the young, like during the age?
Okay, yeah, it could be seen as the imbalance, or it could be a much more getting effective, getting importance of the top-down propagation too. So, yeah, yeah, it was a difficult question. Thank you.
Thank you. Any other questions from the audience?
Yeah,
have a
I had a poster on Monday and Tuesday, but if you want, I brought my poster in my backpack, so I can I can show it right now. Yeah.
One question from the app then. So in terms of your dynamic state calculations, I guess, does the window size matter? And what was the window size?
No, in the complex PCA, it can be represented as the phase. So instead of represent it from the 0 to 20 seconds, it can represent from the 0 to 2 pi for the circulating pattern. So there is no window, fixed window, because we can capture the state for each moment. So yeah, there was no fixed length of the
I see. Okay, thank you again.
Thank you for your attention.
Thank you.